Hello, I'm Logic Bunny, and come with me down the rabbit hole of knowledge.
Ever wondered how your favorite games, those worlds you get lost in, or the apps that connect you to friends, actually work? It often feels like a kind of magic, doesn't it? A hidden force shaping our digital lives, something only a few super smart wizards could possibly understand. Perhaps you felt a tiny flicker of curiosity, a whisper in your mind asking, how do they do that? But then, maybe a wave of doubt washes over you, making it seem too complex, too distant, like a secret language meant for someone else, not for you. That feeling, that quiet sense of being left out of a fascinating world, is real. It can make learning feel like a heavy burden, an obligation instead of an exciting journey. But what if I told you that this digital magic isn't some impossible fortress, guarded by ancient spells, but more like a vast, vibrant playground waiting for you to explore? What if programming isn't about memorizing endless, dry rules, but about speaking a clear, logical language that gives you the power to create, to build, to bring your very own ideas to life? It's a language that, once understood, feels less like a chore and more like unlocking a hidden superpower within yourself. Let's dive into this fascinating world of programming together. Think of it like those amazing Kurzgesagt videos, where something huge and seemingly overwhelming like the entire universe or the intricate workings of a black hole is gently broken down into surprising, bite-sized pieces that suddenly make perfect sense. We'll untangle the threads, one by one, revealing the underlying principles and explanations behind how computers listen and respond. This isn't about becoming a programming pro overnight or drowning in confusing jargon. It's about discovering the quiet joy of logical inquiry, the satisfaction of solving puzzles, and the thrill of watching your instructions transform into action. We'll explore how coding is just like telling a story to a very obedient, very fast listener, the computer. One simple step at a time, we'll journey from being a passive user of technology to an active, imaginative creator. Prepare to have your mind expanded and to discover the amazing code creator that already lives within you. Many of us carry a quiet burden, a feeling that programming is like trying to decipher ancient hieroglyphs, confusing, out of reach, a secret known only to a chosen few. This deep sense of disengagement often comes from the belief that coding is an alien language meant only for the super smart, leading to a fear of inadequacy even before we begin. It's a pain that whispers, "This isn't for you," making the world of creation feel inaccessible. The common distortion, the misconception that builds this wall, is thinking that coding languages are fundamentally different from human languages. We imagine them as rigid, mathematical, and emotionless. But the surprising truth is, these languages were designed by humans, humans, to communicate instructions. It's much like you telling a friend what to do, or a chef following a recipe. It's about clear, sequential commands, not mystical incantations. We need to shatter that expectation that programming is about memorizing complex spells. Instead, it's about understanding simple, logical instructions. Imagine standing before a friendly robot and telling it, step by step, exactly what you want it to do. Walk forward 5 steps, then turn left. That, at its heart, is code. Every complex app, every intricate game, is built from these tiny, easy-to-understand commands woven together like the bricks of a magnificent castle. To help you feel this truth, let's try a simple 3-step technique, a linguistic journey of discovery. First, observe look at a simple piece of code and try to guess what it's trying to accomplish. Second, translate, break it down into plain English, into those simple instructions. Third, experiment, change just one word, one tiny command, and see what happens. This builds confidence, showing you that coding is about logic, not just rote memorization. Think of coding like learning to conduct an orchestra. Each instrument, each line of code code has a simple, specific job, but together, guided by your clear communication, by your logic acting as the baton, they create a magnificent symphony. Your program. It's the elegant power of understanding how to speak to the digital world. A quiet frustration sometimes settles in our minds, a whispered question. Why do I even need to learn code? I'm not going to be a software engineer. This feeling, this wound of irrelevance, stems from a lack of practical connection, making programming seem distant and fueling a quiet apathy. It feels like a skill for someone else, not for the life you live every day. The common distortion, the shadow that obscures our view, is believing that programming only happens inside glowing computer screens or on vast websites. This makes it feel abstract and distant, neglecting the pervasive, invisible influence of code in almost everything we interact with. From the microwave that heats your snack to the traffic lights guiding cars, code is silently at work orchestrating the actions of these everyday objects. But let's shatter that expectation. Code isn't tucked away only in phones. It's the invisible brain behind your smart fridge, your gaming console, and even the self-checkout machine. Understanding basic programming isn't about becoming an engineer. It's about revealing the hidden logic that governs the world around you, transforming seemingly magical technology into understandable systems. It's like gaining a new pair of eyes that let you see the intricate dance of cause and effect everywhere. Let's engage in a kind of reverse engineering in our minds, a symbolic practice of decoding. Think about a simple automated task you encounter daily, like a vending machine dispensing a drink. How does it know what to do? First, it waits. Then, it checks. If a coin is inserted and the correct button is pressed, then dispense the drink and return any change. This simple sequence, this careful ordering of conditions and actions, is an algorithm in action, a tiny program playing out right before your eyes. It's a beautiful example of how clear, step-by-step logic drives the world. Thinking with code, then, is like understanding the secret blueprints of a bustling city. Once you know how the roads or the data flow and the buildings or the functions are connected, you can navigate it better. You can predict how things will work, build your own small structures, and even begin to understand how to fix the occasional traffic jam or a bug that might appear. It's about seeing the elegant framework beneath the surface of everyday life, the quiet fear of inadequacy, the whisper that asks, what if I make a mistake? What if my code doesn't work? This anxiety, this subtle wound often stems from a deep societal pressure for perfection, a belief that errors mean failure, leading to a hesitation to even begin to experiment, to truly explore. It's a heavy feeling, making the journey of discovery feel perilous. There's a common distortion, a cognitive bias that tells us good programmers never make mistakes, or that errors are a sign of weakness, a flaw in our thinking. This belief can stifle curiosity, discouraging us from taking those first brave steps into the unknown, fostering a fixed mindset about our own intelligence and ability to learn complex things like coding. It makes us afraid to even try. But let's shatter that expectation. That programming is a flawless endeavor. In this world, errors, often called bugs, aren't failures at all. They are precious clues. Every oops moment is not a setback, but a fascinating puzzle waiting to be solved. It's a chance to learn something new, a moment of deep inquiry, and a vital step closer to truly understanding how your code, your creation, actually works. It's the ultimate critical thinking exercise, a beautiful dance between problem and solution. When your code breaks, don't panic. Instead, embrace the debugging detective technique. First, read the clue. Pay close attention to the error message. It's trying to tell you something important. Second, isolate the suspect. Figure out which specific part of your code, which instruction, might be causing the problem. Third, test your hypothesis. Make one small, thoughtful change and then run your code again to see if it fixes it. This iterative process, This cycle of observation, hypothesis, and experimentation is the very heartbeat of scientific discovery. Debugging is much like being a curious scientist in a lab. Every failed experiment isn't a dead end, but a valuable piece of data. It helps you refine your hypothesis, adjust your approach, and brings you closer to that groundbreaking discovery. Your code is your experiment, a living thing you are nurturing, and every bug is not a defeat, but an invitation for a profound eureka moment, a chance to understand something deeper about the logic you are building. There's a quiet ache many of us feel, a silent, unmet need. I have so many cool ideas for games or apps, but I just don't know how to build them. This deep desire to create, to bring something new into existence, is often stifled by the intimidation of perceived complexity, leading us to passively consume instead of actively innovate. It's a pain of unexpressed potential, a longing for the power to shape the digital world. The common distortion, the subtle lie that holds us back, is believing that creating anything with code requires years of intense study or a genius IQ. This overlooks the beautiful, modular, building block nature of programming. In reality, even the most complex projects are simply collections of simpler, manageable parts woven together with clear logic and intention. You don't need a superpower to begin. You just need curiosity and a willingness to build. Let's shatter that expectation. Programming gives you the ultimate creative freedom, a kind of digital superpower. With just a few lines of code, you can literally invent new tools, design interactive stories that unfold at your command, or even automate those boring, repetitive tasks that steal your time. It's like having an infinite digital Lego set where you can construct anything you imagine, limited only by the boundaries of your own curiosity. To transform your ideas into reality, let's use a 3-step project blueprint technique. First, ***, dream big, start small. ***, take your grand idea and break it down into the tiniest, most achievable steps. For a game, maybe you first make the character move, then add the ability to jump, then introduce a scoring system. Second, ***, gather your tools. ***, identify the simple code commands, the basic instructions you'll need for that very first small step. Third, ***, build and test. ***, write just a little bit of code, test it to see if it works, then add a little more. This iterative process, this constant cycle of creation and refinement mirrors the very heart of engineering design. Programming is like being an architect of the digital world. You don't merely follow blueprints, you create them. Every line of code you write is a brick. Every function you design is a new room, and your imagination is the blueprint for your incredible digital structure. It's your world, and you get to decide how it's built and how it works. There's an unconfessed belief that sometimes lingers, a quiet thought that learning complex subjects like programming is just about memorizing endless facts and formulas. This misunderstanding, this subtle wound, misses the very heart of what programming truly offers. It's not just about writing code, it's about training your mind to think in a structured, logical way, a skill far more valuable than any single piece of information. The cognitive and emotional factor that often sabotages our critical thinking is the belief that problem solving is an innate talent, something you either have or you don't. This can lead to a quiet despair, making us give up easily when faced with challenges rather than embracing the rewarding process of breaking them down. It feels overwhelming, like a wall too high to climb, but let's shatter that expectation. Programming isn't just for computers or for building the next big app. It's a powerful training ground for your brain, teaching it to tackle any problem, from organizing your cluttered room to planning a complex school project with a systematic, logical approach. It cultivates the profound ability to take a huge, daunting problem and gracefully break it into smaller, manageable pieces, each one a little puzzle waiting to be solved. To help you feel this power, let's explore a logic ladder technique born from the heart of computer science. When you face a tough problem, in code or in life, begin by asking. First, define the goal. What exactly do you want to achieve? Be crystal clear. Second, identify steps. What are the individual actions, the tiny operations needed to reach that goal? Third, order and refine. Put those steps in the right sequence, making sure they flow logically, and then look for ways to make them more efficient, more elegant. This simple, yet profound, process is the very essence of algorithmic thinking, applied gently to your everyday challenges. Learning to code is like upgrading your brain's operating system. It doesn't just equip you with a new skill for the digital world. It fundamentally changes how you approach all challenges, big or small. It transforms you into a master of why, turning every obstacle not into a frustration, but into an exciting new puzzle to solve, a chance for discovery, and a deeper understanding of the world's elegant logic. So, you see, programming isn't some scary monster lurking under the bed, nor is it a secret language whispered only by a chosen few. The initial fear, that quiet sense of being overwhelmed, was understandable, a natural human response to the unknown. But now, you've glimpsed the truth. It is a powerful tool, a vast canvas for your creativity, and a truly fantastic way to sharpen your mind, transforming you into a master problem solver, not just in code, but in every facet of your life. Remember those moments of oops? We learned that every single one is not a failure, but a valuable clue, a vital step forward on your path of discovery. Each line of code you carefully craft, each tiny instruction you give, is a step towards bringing your wildest digital dreams to life. Just like those vibrant experiments you might see on Manual do Mundo, the deepest joy comes from the hands-on discovery, from the moment you finally see your creation come alive, moving, and responding exactly as you intended. It's a profound satisfaction, a quiet triumph of your own logic and persistence. This journey of understanding, this quest for knowledge, is a continuous unfolding. You are not merely learning isolated facts. You are cultivating an intimacy with curiosity itself, with logical inquiry, with the very spirit of discovery. You are building not just programs, but a deeper connection to how the world works, how systems interact, and how your own mind can shape reality. You are becoming someone who understands the blueprints, who can ask why and then courageously seek the answer. The world aches for new ideas, for fresh perspectives, for creators who are willing to dream and then build. So, what will create next? What question burns brightest in your mind? Keep exploring, keep questioning, and keep coding, because you are not just learning programming. You are becoming a creator of the future, a weaver of digital realities. If this journey has sparked a flicker of wonder within you, consider sharing it, for curiosity is our shared superpower. What incredible, mind-bending question will you try to answer with your newfound logic today?